Hello and welcome back to another video. Thought I'd do some more stuff with Spiderman. Trying to work out where things are going. Well, not wrong, but like where things are hiding in memory. So, what I thought I might do is using DOSBox X, we can debug, and I've noted down some things just because like the memory changes based on where you are. But if I break on 3517 1E7 with a column 1E76, is that where I'm looking? Yeah, that's where I'm looking. And I think if I go run that now, so this is gonna happen in a few cases. So it should break. So we've broken. So we've got to the state here. Do we have like other breakpoints? That seems like not the breakpoint that I asked it for, to be honest. Or is that the breakpoint? 176. It is this. Did I actually want a different breakpoint, which was this one? I could copy paste. So I actually want to break at that point. So if we run that, so now we've hit one where we have we're about to do the call into the function that we want. So I would be more interested if, when we're doing this is the values that we are looking at. So I kind of want AX to be 877A. So at the moment it's looking at a different room, but it kind of looks at your room last. So I kind of want to skip over that. So 877A. So now if I go into this step into, yeah. So if we step into that, that means we're now in kind of this area here, and we can see we've got to push a couple of pushes and increment. And what I might do is maybe put that over there, and kind of step through and see whether what I thought would happen happened. And in the time we can also kind of work out where things should be in memory. I need to remember the key to do. So we start off pushing some things. We increment a thing. So we're kind of starting here. So we are going to go to 2. So that looks like it is correct. We go from 1 to 2. We add a bunch to the base pointer. So that does that. And here, this is like running to the SS, which is the special segment, stack segment, special segment, I think. Interesting. I can't recall seeing it ever getting set, but it is what it is. And it is like a different, it's a different number, interestingly. And the I is the 1B5C. That's kind of interesting that this is, it's running to a different location. But that's alright. For decoding, I just really care about what's kind of happening. Given the afternoon sun, I may need to arrange things. Just realised I don't need these headphones on as well. And might do that as well. Sometimes heats up, and I don't know. I have like a few socks on, because if my feet get cold, I find my face nerve gets sore. So I'll just keep warm. what I do. Right, so what are we going to do? We're going to set this to a value, and so hopefully this is going to be base pointer, and base pointer is 92EC, so this is looking good. Need to make sure I don't push the wrong button, otherwise I'll just run and then we kind of lose where we are. So we set that there. It hasn't actually updated it, but surely it has done the thing that I want. Right, so now we are going to set a bunch more, and this is going to end up looking at 153, and that looks right. Now we're going to just put that 5F, that's currently already 5F, so that's kind of interesting. I guess we're like overriding perhaps, yeah, I suppose we might be overriding enemy data from a previous room. Maybe that's kind of what's happening. But yeah, if we step through another one, we should get to this. Now we're going to have a temporary so down here, temporary A, because we are going to end it with that, so we get 71A. Is that what I thought it would happen? 71A, yeah. And so now we're going to store this at DI1, easy. See, interesting, that reads from the DS rather than the SS it was looking at before, though that's with the... Nah, I don't know. Maybe I need to find where move SS is done, which we can do, I think. You can search for instructions. How do you search for instructions? Perhaps okay, how do I do this? Can it not like do the construction for me? Anyway, I kind of wanted to just search for the maybe one of these things. Yeah, I thought it would be able to assemble the instructions for me, so I can just write the mnemonic like move AX into SS, because with these segment registers you can't actually move something directly into them, so the common pattern is that you move something into AX and then move that AX into the stack segment register, whichever register that you are looking at. So anyway, enough of that. So here we're looking at setting that to that, and then put a dot dot dot. Was that just kind of where I was at last time? Maybe that's because I was trying to work out what this was looking at. So here we kind of know that these two values are zeros. Make sure I don't push the wrong one. Get a runaway train. Right, so we kind of add both of those on, and they were both 0. We're only getting a byte out of this one, so we don't actually get the B8, and we can see that we still have 71A, which is what we thought we would have. So now we should be kind of at this point here, so we basically do this, and we like do that, and so I believe this has made DL to be 38, is that right? Yeah, DL is 38, and and then AX is going to be just 1A, yep. Then we're going to multiply that, and we should get DO, easy. Right, so now we're going to get that next thing from the mover tab, which is a B8. I was seeing it before, you'll have to take my word. Right, so, and then this puts it into BL, ends it, so we should have nothing in that bottom register, and then we store this back into our BP, so this should kind of not change that at all. Right, so here we store that, and then we double it at some point. I hadn't actually noted that down. So before we do this, no, perhaps I'm looking in. Right, this will be that. Yeah, so I have missed out a crucial double. So temp BL plus equals, well, times equal to, and find Y and replace it with a T. God, replace it with a T. Replace with T. Right, so this actually has changed things, though we should still just have 0 in this, but it's good to note down what is happening. So BL is 0 on the bottom, so that should do that, and it'll clear the top bit. We add on this instruction, and then here we can see where it is looking. And what for this one here, so we've added on 0, which is quite handy. Because this kind of points to the bottom, the base of the table that it's kind of looking at. And what we can do is change our data view in this DOSBox debugger, and we can say this is pointing to, just realize, yeah, this will, I'll just cover it. My face is covering it. That's all right. We can see our data view to be, it's going to be in a DS, and we want to look at A9E3. And perhaps I'll change this to A9D3, so it shows like a line beforehand. And here we can see some bytes, and it did say that it saw 2 sevens. So what I can do now is in search, we can search for roughly what this is showing us. So we can search for, and it's going to be backwards just because of the way it is. So I don't know, you could search for like the whole thing, but perhaps I'll just search for 2 O's, then 7, 7, 7. And if we search that, we should get 1 match. And if we look here, in the line before we have FFF, and then we have a DB, just like that. And beforehand it is also the same, I'm pretty sure. And then here we have a whole bunch of 7s, then this kind of like pattern. It's not really a pattern, but it kind of goes back and forth. Then the next row has 9A3. So this is where this is pointing, and this is quite handy because it allows us to step through this and kind of work out what's happening a little bit better. And so what this is in essence done, at this point here, we're about to we're about to get that data, add it to DL. So DL currently has 38, and DL came from a bit higher up, I believe. It was meant to be 07, which was just meant to be the whole, the first thing. So in essence, we've got like a few values here. Where did my little thing go? We do some things. So yeah, here at this point, we kind of know that DL is, we got, I think it's the next position for R2D2. And then we offset it by some delta, which was in mover tab. And the index into mover tab, I forget what that was. The index into mover tab was just the current counter. A loop counter. And in mover tab, I guess it has a structure of 3 different things. It has a delta x, I guess you could call it to start with. And then at the end, you're adding like another thing. And it's going to be it's going to be a delta table, I guess. I don't know what to call it just yet. And the index of this table is going to be, so we got a number and we like times it by 2, and then we added on some base. And so this base delta table is this A9E3, I guess. And it's just, I don't know, static when you start up the thing. And what do we want to get out of here? So the delta table, the index of this is going to be a weird thing, which is going to be the mover tab. It's going to be the, maybe I'll call this I, so we can do that. And we're going to get the kind of last value of it, which maybe I'll call a type. But I'm going to end it with 7, which in essence gets the bottom 3 bits. And from there, we can do something like this. I could have done that a little bit better. And in essence, that's what DL is at this point in time, which that is quite handy for when we come to codify this up, that we don't have to do all the stuff that the assembly did to work out all of this. In essence, that is all that's happened. It's also stored a few other values, but pretty much from here onwards, it is just doing that. And the same kind of happens for temp AX, but it is, we get out of that mode, get into that mode. At this point, AX is y plus delta y, and this had it's got 2 U8s in it. And in essence, that's kind of what we've calculated there, and then we store it into the thing. So this is very helpful in understanding what is actually going on. It's kind of weird that they have like 2 deltas, like 2 little offsets to say this is what's happening. And also this whole thing is subtracted 10. Because we get there's a sub 10 or sub 0a. So I think that's in essence what that has generated. So then we can kind of continue on, and this is where we kind of might start to break new ground. So we store that DL, and then we in essence do the same thing for the AX, so we do so we get that 7 from there, so then we get that, but the AX already had a thing. So what do I want to see? Did that equal 35 in the end? It did. And will this equal E8 in the end? It doesn't. It equals CD. I don't really know what the values were beforehand. But perhaps I can kind of work it out. But yeah, because AX was back here, it was sign extended from AL, which was AL was offset by the delta, and then AL was just this it was a temp, which was just the thing masked with that. So that was the getting the XY out of the mask. I had 1A there. Where did this DO come from? 1A, we like multiply it by 8. Which, yeah, that makes sense, but perhaps it was a bit more than multiplying by 8. Because this is potentially like working out the actual like index into an array, and you make a 2-byte index, but it's constructing the 2 bytes itself. But yeah, I don't know, it kind of shows us some things, and I'm happy with that. Just check this. That's all good. So yeah, anyhow. So then we get, this is going AL. Just after we set it to 4, yeah. And then this should get our original one back, 877A, and that was what we started with, wasn't it? Back a few more. So it was 877A, yeah. Right, so then down here, I'm pretty sure that was still doing what I just kind of explained. Right, so we get that, we get 60. We do some dividing. Do some dividing with the top. Easy, doesn't really change anything, and then we like OR that into the bottom, doesn't really change anything, and then we divide it again by 2, does some like weird things, and then that gets us 18, easy, clears that top bit, wasn't set. Here we double it, so we should get 30, easy, and here we get the A9F3, and we can do that same sort of thing. Maybe if we start here first, we can look at the data at A9E3, and this shows A9E3, and it is actually just after where we were looking. So this is the start of the next table, but then the next line down, the 09A3, is that right? Oh yeah, and then that's just like offset by 3. Does that, and then AX we have a bit offset, so we're kind of adding a chunk on. And what I'm kind of interested in is, like, we can just skip over this, these few, is this next instruction, it's going to get a byte from a value, and so where we're looking was like one just over from there, is that right? Yeah, so we're looking at this FF, and so this is, but we're looking at like 30 past that, so we want to add on 1, 2, and 3, so this should be 30 past that. Is that what I'm thinking? A4, E4, and then we got A4, E4. That looks about right, so perhaps we can update this to say this is actually 2D2F in this case, but usually it would be 2D02, is that right? 2D02. No, it wasn't right. It should be 2DFF, because this F3, so it ends with a 3, and we up here we're like adding on a thing to BX, to BX. It ended with a 3, so they should both kind of end with the same thing. And this I've said is 2CF, so yeah, it should just be something F. So it should be 2C, not 2C, 2CFF, yeah, 2CFF, 2CFF there, but we added on like a bunch more. And we can see what AX is actually, it's 1C0. Well, actually, no, BX was what? So AA23, that makes sense. And then the AA26 is where it's reading from, but in G Hydra, that is. So we'll have this, and then add on the 30. So this would be the 2F, and this would be the two values that we're reading at the moment. Cool. And what's important about this is it's reading it into BX and then using that as a address. And so now it could be worthwhile to make sure that this is where we kind of think it is. And so we can look at some of the data there. So 17 A4 D4, A4D4, and this kind of shows that, and at the moment it's looking at this 007F, and this should be like a chunk behind, like like 500 more back. So what we might do is search for this. So if we search for like 82, 82, 82, 80, 0, 2, was that what it was? 82, 82, 0, 2, 0, and that is nothing. 82, 82, 0, 7, F, 0. What if we have just 7F, 0? That's got nothing. Now that's kind of interesting. So perhaps we have written to this chunk of memory at some point. And there's ways to do that. We can see when memory is kind of, memory change, BPM. So what we could do is do a BPM on, say, 3517, and not that, on data segment A4, E4. Right, so now we kind of want to continue on, and then in here we want to like quit, and then start a new game, and here we just kind of want to continue, and we can continue, and we can continue, and continue. We haven't seen where it's loaded the stuff, so what we could do is quit to DOS, I think, and then we can did it like not mount my did it mount a C drive? Right, so can we mount C, and like, do we just have that? And then we can go Spidey. And the thing with DOS is it should still have the same memory addresses. Is that kind of my thinking? Nah, it hasn't. So yeah, I don't know, but that's lost that. But yeah, that's kind of interesting that I couldn't find the other thing that I was kind of looking at. Kind of suggests that we have written to that address somehow, but it did. I don't know. Yeah, it should theoretically. Perhaps it is like getting written to by something else beforehand, but to test that, it's like a little awkward. But I guess now that we know that it's always done that, I kind of want to make sure that I have this. What are all the differences between the things? But BPM, I think, is what I want. BPM, and we wanted that to be golly. What was the DS at that point? I can't recall. No, I think it's not worth starting another debug session, just because it takes a little bit of setup to get to where you want. But I think that was kind of interesting, and we got some idea on like kind of what's happening there. So I think I've kind of said that up in this BP table, and we can start trying to work out what's happening in here. Yeah, and the mover tab we haven't kind of done, but it will just be a static thing. Well, no, mover tab won't be, but the delta table will be static. And yeah. Few different things, because this is like another table, and this table has like a bunch of things that I am not too certain what they all mean. Like it reads in several bytes, and one byte in particular is an address. So I think this is stuff we have written beforehand. Like I just feel like it's something that has just been written beforehand. Like why wouldn't it have been? But yeah, I think that's pretty cool for now. And I think I'll leave it there. Nice and short one. But yeah, hopefully that gives people a view on like how to use various different tools. This one's kind of using a debugger alongside G-Hydra. You can do debugging stuff in here, but like, goodness, I am not sure if it would work. Gosh, one of these there's like some way to do it. Mark and select. Goodness. This tool has just so many things. So like, yeah, you can do a bunch of stuff, but yeah, I think there's a way that you can debug in this, but I think the fact that I'm running 16-bit real mode, like DOS stuff, it would be best to run it under the DOS debugger, because yeah. And like this has, the addresses are quite whack, and like I'm not sure it knows what it's doing half the time, but yeah. Making some progress, so yeah. Hopefully that was interesting to people. I sure found it interesting that there are just kind of static tables to show like a further offset of a position. Perhaps this is showing the like range that it can do, because it is like a moving object, like an enemy. I'm starting to get like enough that I could write a rudimentary parser to show the like the room thing. But yeah, don't know what everything is yet, which that's one of the problems. But half the fun of figuring it all out. But yeah, hopefully you enjoyed that. Nice and short one, kind of using debugger to show things. Didn't make it any further than the line that I've been sitting on for the last, I think, 3 videos, but it made some knowledge progress, which is what's important, and kind of found more things in memory, which I think is important. But yeah, cool. So thanks for that, and hopefully you liked it. Let me know what you think, and I'll see you next time.